Hello students, welcome. Today we are going to discuss some important questions related to general principle and processes of isolation of elements. Basically this unit is about obtaining different type of compounds from the earth crust, and with the purifications and different type of processes we are trying to obtain most purified form of different type of metals. So mainly we are going to discuss about removal of impurities and converting compound form into metallic or elemental form. Okay, so in this unit simple process will be, first we will dug different type of metal compounds from the earth crust. Initially it will be mixed with impurities like dust and sand particles, so we will remove them, and we will try to concentrate our metal compounds. Then we will reduce our metals from compound form into metallic form. That means if it is in compound form, then it will be in positive ionic state. We will reduce it to obtain metallic state, and then with the help of purification we will remove remaining impurities, so we can obtain highest purified metallic elements. So this will be our main process. Okay, so we will follow them, and depending on the nature of the element, different type of processes will be used. So we will discuss some of them, but mainly in this lecture we are going to discuss some important topics related to this unit. So let us start. So when we obtain metal compounds from the earth crust, it is called ores. So ores contains many different type of impurities, earthly impurities, that means sand particles, dust particles, silicas, etc., and other metal compounds and non-metal compounds as well. So we need to remove maximum of these type of impurities so that we can carry out different type of further processes. It is called concentration of ore. This process is called concentration of ores. That means, suppose when we dig metal compound from the earth crust, initially let us say we dig total 100 kilograms of stone, but actual metal content in that 100 kilogram is only, let us say, 5 kilograms. Okay, so that means we have 95 kilograms of impurities. We have to reduce that amount so that we can reduce the cost. That means if you can reduce a majority of the impurities in initial stage, then in later stage no involvement of these type of impurities will be observed, or it will be minimized. That's why cost decreases. So concentration increases the percentage of metal present in early samples or in ores. It is called concentration. Now one of the method of the concentration is called froth flotation method. Now in this method generally we will use sulfide ores. So selection of the methods depends on the nature of the compound. Okay, so that's why sulfide containing metals are generally concentrated by froth flotation method. In this method, GAC, that means impurities as mentioned earlier, earthly impurities, will be removed using this method. So mainly this method is based on different type of attraction towards water and oil. So this is the simple representation of the instrument. We have a rotating pedal. It will be connected with the motor so it can rotate our solution or mixture. So pedal draws air in the liquid or solution, and we have mixture of pulp of ore plus oil with water as well. Okay, so we have actually water and oil, both of them are present inside this mixture. So obviously we know that water and oil do not mix with each other. Similarly, we have two different type of compounds in this solution, which is metal compound plus impurities. Okay, metal compound we need it to separate from impurity. Now impurities are generally earthly impurities, that means sand particles, and generally these sand particles are being wet by water, and metal sulfides do not feel attraction towards the water, but they feel attraction towards oil. Okay, so metal sulfides will be wet by oils. Oil particles feels attraction towards the air particles which are being pumped inside the solution. So that means you will get combination of metal sulfide attracted towards the oil particles attracted towards the air particles, and because of air this whole mixture will become light and it will be separated out as mineral froth from the above. Okay, and you can collect this froth, and then by drying and washing you can obtain your concentrated metal sulfides. So question arises, suppose if we have two different type of metal sulfides in same mixture, then how can we remove one of the metal sulfide to obtain second metal sulfide in concentrated form? So as mentioned here, the sometimes it is possible to separate two sulfide ores by adjusting proportion of oil to water by using depressant. For example, in case of ore containing ZnS and PbS, the depressant used is CnACN, sodium cyanide. It selectively prevents ZnS from coming to the froth but allows PbS to come with the froth. So that means you can collect PbS separately, and ZnS will remain inside the solution because of depressant NaCN. Now after concentration, next step will be extraction of crude metal from concentrated ore. That means we already removed mostly earthly impurities, and now we have concentrated metal compound. So to reduce metal impurities we can do extraction of crude metal from concentrated ore. That means our concentrated ore still contains some impurities, and we can reduce them using extraction methods. One of the extraction method is roasting. So as we can see, we have some instrumentation or furnace here, and this furnace mainly oxidizes sulfide ores into oxide ores. As you can see here, we have ZnS, PbS or Cu2s. All of them will react with oxygen and it will create metal oxides ZnO, PbO and Cu2O, and sulfur dioxide gas will be removed from it. Now if you have some impurities, metal impurities alongside with our main metal, then we can remove those metals using silica, that means SiO2. SiO2 mainly reacts with reactive metals, and we can create metal slag using silica. As for example, suppose if you want to abstract copper from this method, then if Fe or iron impurity is also present, then it will participate in oxidation reaction. That means if you have FeS and Cu2s, both of them at the same time, FeS is more reactive than Cu2s. That means iron metal is more reactive than copper metal. That's why it will participate in reaction first and we cannot remove it. To reduce the interaction of Fe, we can add silica into the compound or into the mixture. Fe being more reactive, it will first participate with the reaction of silica, as we can see in the reaction 6.12. FeO with SiO2 creates FeSiO3, which is known as iron slag. Now slag compounds are generally lightweight, so when we melt all of this mixture, slag will float on the molten mixture, so we can remove it from the remaining compound. Okay, so slag is one type of impurity removal process. Slags are generally lightweight compounds, so it will float on molten mixture. Now extraction of some noble metals, that means less reactive or non-reactive metals like gold, silver or platinum, is done by some different type of methods, mainly chemical methods. So as mentioned here, extraction of gold and silver involves leaching the metal with Cn minus ion. This is also oxidation reaction, that means metals will increase their oxidation state, but in later stage it will be reduced again to obtain pure metal. So reaction is mentioned, so let us discuss the reaction. So basically it is two-step reaction. First of all, we have metal solid. It will react with cyanide ions in presence of water and oxygen, and it will create a complex compound, as we can see here. Now this complex compound is water soluble compound, and OH minus ion produced during this reaction is also water soluble. That means initially insoluble metal is converted into soluble compound. Now this soluble compound, when react with zinc, it will be reduced again. That means you will get your gold in metallic form back, which is now again insoluble in water, and zinc compound which is soluble in water. So now question arises, why we are oxidizing our metal? It is already in metallic state and we need it in metallic state. Then why we are doing this process? So answer is, initially this metal is impure. It contains some impurities. Okay. So problem is, our metal and impurities, both of them are insoluble in water. That means they will not dissolve in water. So initially we are converting our insoluble metal into soluble one. Okay. So now metal will be soluble inside the water and impurities will not. So simply dissolve these metal compounds into water and then filter it, so impurities will be removed, and filtrate contains our metal soluble compound. With the help of zinc, again you can convert it into metallic form which will be insoluble. That means with the filtration you can separate metal from the remaining solution. Okay, so this is method to abstract metal, actually noble metals like gold, silver, platinum.